Hello everyone, today I'm going to walk you through how to create your own item and equipment system, partially as a tutorial and partially to motivate me to work on my own game. This will be part 1 of a 5-part series that will go in depth on how to create your own item system. From the very basics of creating and managing your items, to incorporating enchantments, on-use effects, player inventory, equipment, and more. We will be using some intermediate programming techniques such as inheritance, link queries, and reflections. So if you don't understand anything, just leave a comment and I will help you as best as I can. And if you can't be bothered to follow along with this tutorial, then the finished scripts for this video will be linked in the description below. So all that being said, let's begin. So we'll start off with a blank Unity project, and we will start creating our folders that we need. So our scripts folder, and we will create another folder called databases. Now, in the scripts folder, we will go ahead and create another folder called systems. And then we will create items and equipment. And we will go ahead and create our first C# class called item. And we'll just let this compile. Just let Unity do its thing as it reloads our domain. And cool. And now we will open up our item script. Okay. So we don't need any of this stuff that Unity starts us off with, so you can get rid of the base methods and the inheritance from mono behavior. So now we're going to start filling in our item class. So we'll call this section base item data. These are going to be things like the public sprite icon, the public string ID, the name, description, public game object, model. And basically all of these things are things that every item should have. Unless you're working in, say, 2D games, in which case model isn't really necessary, or if you don't want to have the player be able to drop their items. So now let's go on to the next section, which is item flags. And these are flags, essentially a set of booleans that inform how the item works. So for instance, we have a public bool is quest item. Now, perhaps you don't want a quest item to be deleted. Perhaps you want to keep track of what every single quest item is. So that's what these are for, these flags. So we'll add a few more, is unique, meaning should the player only have one of them in their inventory. Player bool is stackable. Public bool has on use. Public bool is enchanted. Gives stats. Can buy. And can sell. So all of that sort of informs what the player can do and can't do with the item. Is it enchanted? So can it be re-enchanted? Do you have to disenchant first? Does it give stats? Can you buy it from a vendor? Can you sell it to a vendor? All of that is then informed later on by our item flags additional data. This will be public int stack limit. So we'll say it can be stacked, but to what limit? Public string on use script, public string on use method, string enchantment script, enchantment method, public quote buy price, sell price. Alright, lovely. Now these four will be relevant in part 3. So right now, we don't need to worry about them. We'll be dealing with them in part 3. Now, you may notice that this is all well and good for a basic item. But what if I want to create a weapon, or a piece of armor, or a book? All of those have attributes that certain items just don't need to know about. If you create a book, a weapon doesn't need to know how many possible pages there are. So that's how we're going to do this with the public abstract class item data. And so we're going to add up here. We're going to call this type data, public item data. Alright. So now what we're going to do is we're going to create public class armor and inherit it from item data. And we'll create a few others. Public class book, inherit from item data. Public class consumable, also inherit from item data. And I think you see where I'm going with it. So what we're going to do is, because everything we're going to create inherits from item data, it means they can freely be swapped in and out of this data variable. It means that if we say here in the armor class, if we give it a public enum of slot type, head, shoulders, chest, gloves, legs, and boots. We'll add a public slot type slot and a public float of defense. Cool. And we will create a public list. Make sure it's not the end unit, your list of string. And we'll call this pages. Okay. So now if we go to our item data and we say, hey, I want this item data to be a piece of armor, then it will say, okay, it will list inside of this item data, it will list the slot type and the defense value, but it won't care about the book pages because it's an armor item data, not a book item data. So that's how we're going to handle specific types of items. So we're going to go ahead and create the other types of items and just fill in everything that we need to know. So public enum book type. So it's a book. Letter. Scroll. Or is it torn paper? And go ahead and just add public value, public float time, public class, miscellaneous, I always get that one wrong, which inherits from item data, public class resource, which also inherits from item data. Enum resource type. Is it a leather? Is it ore? Is it cloth? Is it an ingot? Etc. And finally, we're going to create public class weapon, which inherits from item data. So, I'm going to have public enum weapon type. And this can be whatever weapon type you want. So if you want it to be pistols, if you want it to be a revolver, a shotgun, a dagger, sword, spear, or a two-handed axe. Public float min damage, public float max damage, public float call it range, and public float attack timer. Okay. Go away. Lovely. So now, because of how we've set up the item data, we can swap between armor or books or consumables, and we will do this by having a drop-down menu. So let's switch back to Unity, because the item class is done for now. We'll let it compile. Alright. And we will now create another class, which we will call item database. I'm sure several of you can see where this is going. Alright, and get rid of the starting methods because we don't need that. But instead of getting rid of the inheritance from mono behavior, we're going to swap it to inheritance from scriptable object. We're going to add a attribute to it called create asset menu. File name is new item database. Menu name my game backslash new item database. And we will just call this public list, make sure it's not the end unit framework again, of type item. Put all items as a new list. Okay. And that's that done for now. So we'll just go back to Unity, let it compile. And we'll head on to databases and we will go create my game new item database. And we will call this database. Okay. What have I done wrong? Item. Of course. Yep, so make sure your item is serializable. And then we can wait for Unity to recompile. And that's on. Alright, love it. So we'll create a new item, and then you can see it's got the icon here. So if we go down, just the knob. We've got the ID, which is pretty cool, you know. Name, the name is the name. You know, and we've got all these things. What we don't have, you might notice, is we don't have the item data. And the reason for that is because Unity doesn't really know how to handle it. It doesn't know how to handle it inside of the inspector. It knows how to handle it outside of it. It's fine with that, to an extent. So what we're going to do is we're going to go back to our item class, and just below here, we're going to create our public what is it? There we go. Public class show subclass attribute, and it's inherited from a property attribute. Now we're going to go to type data and we're going to add 2 attributes to it. First is serialized reference, and the second is our newer attribute, show subclass. All right. So now we need to go back to Unity, and we're not ready to have it appear just yet. As you can see, it appears as data, which is good, but it does not have all the subsequent data that we need. So we'll go to scripts, create a new folder with editor, and in the editor, we are going to create a new class called show subclass drawer. Okay. So go away. Alright. So we'll get rid of this, and instead of inheriting from model behavior, we're going to inherit from property drawer. We're going to add a attribute of custom property drawer, type of show subclass attribute. Okay, now we'll get into the more complex part of this tutorial. So, first of all, let's create a private static dictionary of type and a list of type, which we're going to call subclass cache. Okay. Now, private list of type get subclasses type base class. Okay, now if subclasses cache dot subclass, I'll call it subclass cache dot try get value base class out list type called subclass list. Return subclass list. Okay, so basically what we're doing here is we're checking to see the subclasses of our type. So we're going to input our item data class. It's going to see if it's in the subclass cache, and then if it is, then it's going to return the subclass list. If it's not, then we're going to continue on with the coding. But the reason we're doing this is, the reason we're putting it inside of cache is because it's very expensive memory-wise to try to constantly get the subclasses. Because the way it works is that the attribute will constantly be trying to get the subclasses. It doesn't run just once, it runs multiple times. Multiple times a second, I believe. And so by putting it in a cache, we get rid of it constantly looping through the very expensive method, and instead it just tries to get it from the cache instead. So, now for the expensive method. So we'll create a list of type that we call subclasses. The app domain dot parent domain dot get assemblies dot, and here is where the link queries come in. Select many assembly dot get types dot where type is equal to base class dot is assignable from t and t dot is class, and T is not abstract, and T does not equal base class. God, two bits. And then turn subclasses cache base class is equal to subclasses, and then return subclasses. So basically what we're doing here is we're searching through the entire app domain, which is basically your entire program, your entire solution, and we're getting all the assemblies, we're selecting all of the types, we're saying, so basically we're just getting all of the classes that exist in the entire assembly. And I believe that that does include reference assemblies as well. I'm pretty sure. I'm not 100% sure, but I'm pretty sure. We're then getting the types, all of the classes, and we're saying, hey, are you assignable from T? Meaning, are you a subclass of type T? Are you a class in and of yourself? Are you not an abstract class? Because an abstract class doesn't work in the same way a non-abstract class does. And then we're just making sure that T is not the same as the base class. Then we're creating a list, and we're setting the subclass cache of the base class to subclasses. So we're now storing all of the subclasses that we have just gotten in this method, and then we were returning it. So that is handling getting the subclasses. Now we need to handle how we're actually going to show off these subclasses in Unity's inspector, and how we're going to create our drop-down menu so we can select the armor of a book, of a weapon, of a resource, or whatever. So now we're going to create a public override. First of all, get on GUI, and then public override our get property height. These are two classes that Unity have basically included as part of the property draw, and we're overriding them through inheritance. So let's get rid of this. Now this is quite a lengthy part of the script, so I'm just going to go through it and I'm just going to explain it afterwards. Okay? So type base class is equal to field info, field type, list of type, subclasses is equal to get subclasses, base class, if subclasses dot count is equal to 0, label field, pass it the position, the label dot text, and the message no subclasses found, and then return. If property dot managed reference value is equal to null, property dot managed reference value is equal to an activator dot create instance of subclasses 0. Property dot serialize object dot apply modified properties. Type, current type, property dot managed reference value dot get type int current index is equal to subclasses dot index of current type. If current type is equal to -1, then current type, so it's current index, it should be equal to 0. String type names is equal to subclasses dot select. We're just going to capitalize here to keep with our naming scheme. Alright. Okay. Rect. Pop up. Rect. New rect. We will pass in our position.x, position.y, our position.width, and the editor GUI layout utility single line height. Then we will create int new index is equal to editor GUI dot pop-up. Pass it the pop-up vect, the label dot text, the current index, and the type names. And then we will say if the new index does not equal the current index, property dot manage reference value is equal to activator dot create instance of our subclasses new index, and apply the modify properties, and then editor GUI property field, and pass it the position, the property, the label, and true. Okay, that seems very complicated. It's really not. Let me break it down. Basically, we're getting the type of the base class from the field type. So if I go to Unity, we'll wait for it to compile. All of these are basically the field. These are the field types. So this is a field type of a type string. This is a field type of a type string. This is a field type of the type game object. This will be a field type of the item data type. So it's basically just getting all of that. Okay. So that's what that is. We're then going to check, hey, does it even have any subclasses? If it doesn't, we'll return a label field, which sort of acts like this, but just sort of over here. That says, hey, we didn't find any subclasses. Now then, if we did find any subclasses, and if the managed reference value, which would be this value here, is null, then we should set it to the first subclass, because we don't want it set to a base item data, because the base item data has nothing. It then going to apply modified properties, and what this is going to do is it's going to create and serialize all of our properties. So when we select armor, it'll create in here, it'll create slot type, it'll create defense value, all that sort of stuff. So we then get the current type of the managed reference value, because remember, this only runs if it is null. So if it's not null, then we need to know what the type is. So we'll get the current index of the type, which in our case is our armor, which is type index 0. We'll make sure it's not a negative index because that is something that is possible, but it rarely happens. It's just sort of a catch me, really. We'll get the type names, and this is for our drop down. We're creating what the drop down is going to be, where its position is, how wide it should be, how long it should be, you know, that sort of thing. Then we're getting the index from the pop-up. So we're basically getting whatever we select from the pop-up, which is our drop down, we're getting the index of. We'll then say, hey, is this index the same as the current index? If it's not, then it'll create a new instance of that subclass. So basically, if I select weapon, but we're currently on armor, it will get rid of the manage reference value, which is a type of armor, and it will create a new instance of our subclass weapon. It will then serialize everything that we need, and it will create property fields. So that's that in a nutshell. And so now all we need to do is we just need to go here and we need to return editor GUI dot get property height property label true. Okay, and that is everything. So now we will go back to Unity, it will compile, and you can now see just here that we've got armor, book, and so now we can freely swap between the two. So if we add, say, 5 pages, but we swap to armor, well, he doesn't need to know about those 5 pages. If we swap to resource, we can choose a cloth, or we can go back to weapon. And all of these, basically, because all of these are their own separate class, it means we don't have to waste a lot of time creating lots of different fields for various item datas. So, yeah. So that is the end of part 1 of 5. Part 2 shouldn't take me that long. And so, yeah. If you like any of the music that I've been using, it's by Stephen Melin. Check him out. This is called SAGA. It's on the Unity store. Both YouTube and I would appreciate it if you liked the video and subscribe to the channel. Thanks for watching, and goodbye for now.